The least squares method. The least squares method. So here's our two lines, our y and our x-axis. Y, of course, is our dependent variable, and our x-axis is our independent variable. So what's going to be depending on x? Sales of ice cream. So as the temperature goes up, 1 equals 10 centigrade, all the way up to 550, uh, our sales will go up. As you can see, the line actually kind of shows that it actually does. All right, so here's 1, x1, y2, x2, y4, x3, y5, yeah, it's 5, and then x4, y4, x5, and y5. Now, if it gets up to 50 degrees centigrade, you're going to probably not survive anyway, so you won't buy any ice cream. So this probably should be down here somewhere. Okay, now here's our numbers. We took these and slapped them up into here, x1, y2, etc., etc. So what we're going to do now is we're going to get the average from each of these columns. Okay, so that's our mean for x. This is our mean for y. Mean means the average. I think you know how to do that. Okay, so now we're going to take our x data points and subtract the average the mean from each of those data points. And that's what this x bar, they call it x bar. We're going to subtract our mean from our data points. All right, so we're dealing with the x right now. All right, and this is the results. -2, -1, 0, 1, and 2. All right, so what we do now with these numbers is we square them. 2 squared is 4, -1 squared is 1, etc., on and on. All right, so we square that. The reason we square those numbers is because we don't want any negative x values. And then we take those squared numbers and add them up. Now we're going to deal with our y. So we don't square our y, but we do take the mean of the y and subtract it from our y data. So here's our y data. So we take our y data and subtract the mean. All right. So and this is our results. And now what we do is a whole different thing here. We take these values here that we got from this column, x minus the x mean, and we multiply it by y minus the y mean, which is this column right here. This column right here. Sorry, this column right here. So we're multiplying this column with this column. Got that? So -2 times -2 is 4. -1 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 2 times 1 is 2. All right, so we're going to add these numbers up now. Okay, so now we have all the numbers we need for our equation. And this is our equation. Y equals b's of O plus b's of 1 times x. All right, we have all our numbers here. These are the numbers we're using in this equation. So b is our slope, and right now it is what we're trying to find. Okay, what happened here was we took this column and we added it up, and this becomes our denominator. In this column we added up, this becomes our numerator. Just try to remember that. Now what is this number? It's 0.6. And we had a formula for that. So this is our formula here. And this is what we did here, up here, which became 6. And this is what we did down here, which became 10. Now, this E here, it's actually called sigma. But what that means is just sum. It just means add up. You probably already know that. All right, now, what do we got here? Well, we have, remember over here was 4, was the Y. So this is our Y over here, it's 4. And our X was 3. And remember, this was B1, right? We just said that this was B1. So we put the B1 here. That's where it goes. And the X was 3 right here. All right. So notice that the 3 and the 4 is where the lines crossed. All right. So now all we have to do to find B's of O is just some plain old algebra. And of course, 0.6 times 3 is minus 1 is 1.8. 6.3 0.6 times 3 is 1.8. So we subtract that from each side, right? So what's 4 minus 1.8? That's 2.2. This here we subtracted from this side. Of course, 0.6 times 3 is 1.8. So that this cancels out. And we're left here with 2.2 equals B's of O, which is our y-intercept. And if you look over here, it does look like it's around that area, 2.2. Yeah, 2.2. And that's how we do the least squares method.